Okay, so in section 3.3, we're going to write equations of tangent lines and normal lines. So they're very similar. If you look at the first box, I typically start with point slope form. So this is point slope form. Y minus y1 equals m, your tangent slope, x minus x1. So we will need the tangent slope from the derivative and a specific point. For free response questions, if you set it up in point slope form, you can leave it. You do not have to simplify it. That's why we choose this form. On multiple choice, it's usually set up this way as well. If you're doing this on homework, you can use other equations of lines like slope intercept and stuff like that. But it's just a matter of flexibility. So step one, find the derivative, which is your tangent slope at a general point. Plug in the x value to find your specific tangent slope, and then we need to find the y value. Sometimes they give you the point, sometimes they don't, but the y value is on the original function, okay? For normal lines, you're going to find perpendicular slopes. So let's look at our diagram because that shows you the difference. So a tangent line will be kind of touching the curve. It can go through the function, things like that. But a normal line is actually perpendicular to the tangent. So you will still find the derivative of the tangent slope, and then when you want the normal line, you'll do the perpendicular slope is the opposite and the reciprocal. That's why it's called negative reciprocals, but really I like the word opposite and reciprocal slopes from the tangent. Okay, so that's it. I don't memorize these formulas, but that's how I use them. Okay. All right, so on example 1, we're going to have the function x cubed minus 4x squared. So if I want to write the equation of that tangent line, we're going to do both just to get some practice. So we're going to find our derivative. So we're going to use the power rule. Okay. And then if we want the specific tangent slope, we're going to substitute x equals 3. So we get so we get 27 minus 24, and our tangent slope is 3. Okay, so if we wanted to write the equation of the line, we are given the point. So we would have y minus the y value equals our slope, x minus this x value. And on an AP exam, you can go ahead and leave your answer like that. Okay, so now if I want the normal line, then you're going to use, I'm going to write normal line. So if our tangent slope is 3, we need the reciprocal, which is 1/3, and we need the opposite sign. So this would be my tangent line slope. And so everything else is going to be similar. So we would have y, it's still at the same point, and we just substitute the different slope. Okay, so that's it. All right, on example number 2, you'll recognize that that's an implicit derivative. So we need to remember how to do the derivatives of any functions. So I'm going to rewrite this as a power. So if we want to find our derivative, we do 1/2 x to the negative 1/2, do our power rule. Remember that we did a y, so we do need dy dx. The derivative of -1 is 0. The derivative of y is 1 dy dx. I like to put the 1 there because remember we're going to factor it out. So I need to get my dy dx terms on the same side. So I'm going to leave this alone. I'll rewrite it in the process. And I get 1. And then we'll subtract. I'm just rewriting it. Okay. We can factor out a dy dx. And then divide. And I don't worry about rationalizing anything because remember we are going to plug in the point value. So I just leave that alone. Okay, and so now we want to substitute to find our tangent slope. So tangent slope, I like to label what I'm finding. X is 9 and y is 4. So I get square root of 9 is 3, so 1/6 over 1 minus square root of 4 is 2, so 1/4. So I get 1 over 6. That would be 3/4. So remember, you multiply by the reciprocal. And I always assumed that you wouldn't have a calculator, so I'm going to reduce. So my tangent slope, I do need a lot more room, is 2 over 9. Okay, so then my equation of a line is y minus y equals m x minus x. Okay, we could leave that for the free response. You can leave that on my homework too. The normal line, so I'm going to write tangent would be y minus y, and I'm going to take the reciprocal and the opposite sign. Okay, so we can do any kind of derivative there is. All right, let's look at our third example. So we do have two different functions that are being divided, so we will have to do a quotient rule. So low d high minus high, and then the derivative cosine is negative sine, all over low squared. Then we're going to substitute x as pi, so f prime of pi. This will find our tangent slope. So the cosine of pi times 2, I'm going to put the 2 in front, 2 pi, actually that's 2 negatives, make a positive, sine of pi, all over the cosine of pi squared. So remember your waves. So this is sine. Pi is right here. So the sine of pi is 0. So that all goes to 0. Cosine at pi, because that's pi over 2, is negative 1. So let's get a different color. So this is negative 1. This is negative 1. So our tangent slope is negative 2 plus 0 all over negative 1 squared is 1, so negative 2. So y minus y equals m x minus x, and that's our tangent. Our normal slope, normal equation, sorry, is the opposite sign, so it's going to be positive this time, and 1 over 2. And that would be our normal. Okay. All right. Now we can also find specific tangent values. So like horizontal tangents and vertical tangents are pretty popular. So remember, a horizontal tangent means I would have a curve and I would have a horizontal tangent line. So what we know is that our tangent slope is 0. If we have a vertical tangent, then that means our slope is undefined, and that happens when the denominator is equal to 0. So if it's a horizontal tangent, it actually meant your numerator, if you do have a fraction, is equal to 0. Okay? Or the entire function. So on this example, find the x values. Notice we don't want the points, and that's basically to save time, where we have a horizontal tangent. So what I know is that's where my derivative equals 0. So we do have a quotient rule. So we get low d high minus high d low all over low squared. So if we're setting this derivative equal to 0, we could really multiply by the denominator. That's why the denominator is irrelevant. So I could distribute, but I'm actually going to factor out a 2x just a different strategy because I have these two terms and they both have a 2x in common. So then I'm left with x squared plus 1 minus that x squared minus 3. And since I'm setting it equal to 0, factored form is better because then I can just split them up and solve. So divide by 2. So at x equals 0, I would have a horizontal tangent. My x squareds actually cancel out, and I'm left with 4 equals 0, which doesn't have anything to solve, so that didn't give us another solution. So there's only one x value that has a horizontal tangent. All right, our next question says determine the points. So now I do want a point. I need an x and a y, but look at the original function. That is a horizontal tangent line. So once again, my derivative is equal to 0. So here's our derivative. We're going to set that equal to 0. We could factor or we could actually just solve. So I'm going to add 9, divide by 3, and take the square root. Remember, when you take a square root, it is plus and minus. So I actually have 2 x values. And we're going to plug that into the original. So if I take root 3, and this would be without a calculator, or I could use the calculator, but we're just going to go ahead and write. So it would be the square root of 3 cubed minus 9 times root 3. They might want the x value or the point, so just be flexible. It's not a super great answer, just because the answer was a root. And then if we plug in a negative root 3, it's going to be really similar, except I'm going to have, it's still going to be negative. So negative root 3, I can put the negative in front, and that'll be a negative root 3, which makes it positive 9 root 3. Okay, now those typically are not the y values on an AP test or my test, but the idea is the same. Okay, and then you've got your practice. So, okay, but that's the idea. Go ahead and give it a try. Let me know if you have any questions on the idea.